We're ready. Okay, so what is the integral of sine of x? Negative cosine x plus c. What is the integral of cosine? Sine x plus c. What's the integral of secant squared x dx? Tangent of x plus c. What's the integral of cosecant squared x? Negative cotangent of x plus c. Notice the angles match, right? If they use thetas, it would be thetas. If they use y's, it would be y's. Whatever the variable they give you, it matches, yes? Okay, what is the integral of secant x tangent x? Secant x plus c. What is the integral of cosecant x cotangent x? Hang on a second. I'm trying to get rid of this. Oh, what are you doing? Okay, okay. There we go. Here we go. It's what? Negative cosecant of x plus c. All right. Here's the tricky one. I have secant of 2x and tangent of 2x. Notice the angles match. Is there an a there? Is this that whole a thing? Okay, so what is the integral of a trig function that has the ax? 1 over a, right? So it's just like the one above, only instead of secant x, it's 1 over, what's my a? 2 secant of what? 2x plus c. That wasn't bad. In fact, I'd say it was
Más simple.
What's the integral of cosecant of 3x cotangent of 3x? What's the a? 3, so it's 1 over 3 cosecant of, let's do it all in one. So and then because there's no negative, it has to be negative plus c. 3 parts if it's a trig function, it starts with a c. The answer is there's 3 parts. One, you got to deal with the a, then you got to deal with which trig function is, and then you got to deal with the negative sign. Yeah? Easy peasy, lemon squeezy. Got it? Okay, clear off your desk. It's time for a quiz. It's going to make me do something else. Hopefully, it's actually recording. I'll be darned. Something, I don't know. Sometimes it works, sometimes it doesn't. So, this is the notes for section 5.1, day 4. Is this important? And we're just doing miscellaneous. These are the ones you screw up, and I'm going to go over them again. That's really what this is. Okay, what if, and these are a little different. I'm going to show you how to do these the hard way, and then later on I'll show you an easier way. But for right now, it's in the textbook in this section before we've done U-sub, so I got to show you the hard way. And then I'll show you an easier way later on, but y'all aren't ready for the easy way. Okay, so some of the questions, it was y equal to, can y'all see that? Is that bold enough? Yeah. Okay. Y equal to integral of 2 over, and it was 16x squared plus 25 dx. And that's clearly an inverse tangent, but that thing is not just x. So what we have to do is we have to factor out a 16. So I'm going to pull the 2 out that's up on top because I want a 1 on top anyway. And then down in the denominator, if I pull out the 16, it's x squared plus 25 over 16, right? Does that make sense? Let's just do an algebra trick. We'll pull the 16 all the way out, and that becomes 2 over 16 integral of 1 over x squared plus 25 over 16 dx. Now does it look like the inverse tangent formula I gave you? Yeah, it does. I need this to be a little thicker. There we go. So now when you do it, you just go, okay, I want this is a squared. So a is equal, what's the square root of 25? And what's the square root of 16? And that's x squared, so I just want x. That we know that it's tangent, so from the formula, do we always have to do 1 over the a? Okay, 1 over this, is 1 over a fraction? Am I going to flip it to get the reciprocal? Right? So this is 4/5, because it's 1 over a. 1 over a is equal to 1 over 5/4, which means I have to flip it 4/5, right? Tangent inverse, what's the it's x on top, what's on the bottom is the a, so I'm dividing by the 5/4 again. Am I going to have to flip it? So what does this ultimately equal? It equals 4/5 tangent inverse of 4x over 5 plus, I got my plus c. Right? You'll be okay with that. Do you remember the formulas? I'm going back so I can show you the formulas. Here they are. See the formula right here? Remember inverse tangent? You got a squared, you got x squared. You got to do x over a, so that means I'm going to get a little bit through the whole flip reciprocal thing, right? Okay. That wasn't that bad. But is that how you handle it if it's not x squared? If the x has a coefficient, is that what you're going to have to do? You're going to do some algebra. No big deal, right? All right, another tricky one. Why am I doing these? Because this is what people asked me about. So if y'all ask me questions, this is what I do. So the next one is y equal to the integral of 10x to the 5th minus 3 over x dx. Y'all know quotient rule. Are there two things on top and one on bottom? Now the two things on top separated by a plus or a minus. Then you can break this into two fractions, right? We did this with limits. We did this with derivatives. You have to do this with integrals. You have to do the algebra first. So this is going to become the integral of 10x to the 5th over x minus 3 over x dx. We're going to rewrite those. How can you simplify 10x to the 5th divided by x? How can I write 3 divided by x so that I can do the power rule? 3x to the negative 1. Actually, I don't want to do that. I don't want to do that. Actually, what I want to do is, because I want this to be obvious to y'all, I'm going to write this as two different integrals. Here you'll see why. This is dx, and this is minus 3 integral of 1 over x dx. Why did I do that? Are you supposed to recognize what 1 over x dx is equal to? Whose derivative is 1 over x? Natural log. Can the argument of natural log be negative? No. How do you force a number to be positive? Absolute value. Got it? So, using power rule in reverse, what's the integral of 10x to the 4th? So 10's the coefficient. We just leave that there. What's the new power? Over 5 minus 3 natural log absolute value of x. This is because it has to have a positive argument. Plus c. Simplify it, you just get 2x to the 5th minus 3 natural log absolute value of x plus c. Easy peasy lemon squeezy. If you break it into different fractions. If you don't, I don't know what you're going to do. I really don't. Because it's whatever it is, it's bad math. If you didn't do that. Because you don't know how to do it. You don't have to deal. Y'all don't know how to deal with a fraction, a rational function, which is the fraction of two functions. Next, my next pet peeve, or next most commonly asked question: y equals the integral of the cube root x squared dx. How would you write the power in order to integrate that? X to what power? 3 halves? Yeah? 3/2 dx, and then it gets easy, right? What's the new power? Add 1 to it. 5/2. Divide by 5/2 is the same as multiplying by 2/5, right? I'm done. Okay, what if they mess with you on the trig front? They give you the integral of tangent of x over secant of x. Well, here's the problem. You don't know how to deal with a fraction, right? So how about we break these down? Whenever you're simplifying trig functions, do you always write them in terms of sine and cosine? Well, you should have learned that by now, but so tangent is sine of x over cosine of x. That's the upper fraction. The lower fraction, secant, is 1 over cosine of x. For those of you who can see that you can cross out the cosine already, go ahead and do that. If not, dividing by a fraction is multiplying by the reciprocal. There's tangent of x. And then flip this one, it's cosine of x over 1. Guess what? Becomes 1. And is this just the integral of sine of x? What is the integral of sine of... Oops. Didn't mean to change colors. What's the integral of sine of x? That was easy. Hang on.
That was easy. Rien de plus simple.
But wait! There's more. How else could I make this complicated? What if we are integrating x squared minus 1 squared over x squared dx? Is this like that other one where I had two things on top, but I got to do two things in algebra? I got to square the binomial, and then I got to simplify. So when we square, that's when I multiply x squared minus 1 times x squared minus 1, I get x to the 4th minus 2x squared plus 1, right? Does everybody recognize how to do that? If you need to show the work, show the work. And it's all over x squared. I don't want to do division, so am I going to break it into 3 fractions? So this becomes the integral of x to the 4th over x squared minus 2x squared over x squared plus, this is going to be 1 over x squared, but do I really want to write that as a negative power? Because I'm going to do power rule. Simplify these other two. What's the first term? X squared minus 2, because the x squareds cancel out, plus x to the negative 2 dx. Is that going to be easy to integrate now? What's the antiderivative of x squared? What's the antiderivative of 2? 2x. What is the antiderivative of x to the negative 2? It's going to be x to the negative 1 over, I already put the negative there. It's negative 1. I just did minus. Plus c. Get rid of the negative. Oops, power, I messed up.
就是这么简单。
What do you think? Take a little practice, but should it be easy if you practice? Yeah. Nothing beyond your abilities. But wait! There's other favorites of mine. Yeah, there are. What if I give you y equals to the integral of 5 over cosine of x cotangent of x dx? You don't want to leave it that way, do you? Pull out the 5. Write it as the 1 over cosine of x, 1 over cotangent of x dx. What is the reciprocal of cosine? Secant. What's the reciprocal of cotangent? Oh, this is scary. Tangent. Now, can you integrate it? Did they just hide it in the reciprocal relationships you were supposed to learn last year? So it's going to be 5. What? We did this in the warm-up. Whose derivative is secant x tangent x? Secant x.
É tão fácil.
But wait, I got another favorite. Yeah, what if it's y equal to the integral of 1 plus cotangent squared of x? Just before you start digging yourself in a hole, we don't know how to integrate cotangent squared x yet. But if you remember any trig from last year, trig identities, Pythagorean theorem, what's 1 plus cotangent squared x equal? Do you remember? How about cosecant squared x? Y'all don't remember anything. Well, it does. This equals the integral of cosecant squared x dx. They expect you to know the Pythagorean theorems. They expect you to know the double angles. So when we're doing this, sine of 2 theta equals 2 sine x cosine x is fair game. All the Pythagorean theorems, which is 1 equals sine x squared plus cosine squared x, right? Do y'all know how to get from the Pythagorean theorem, the very first one with sine squared and cosine squared, to the other ones? Because it appears now. No? Okay, let's go through that. Well, actually, let's finish the problem. So whose derivative is cosine squared x? But it's going to be negative cotangent of x plus c. It's easy if you know your trig identities. It's not if you don't. So on the very first week, I put a unit circle up there with the trig identities you were supposed to memorize for AB calculus. This is one set of them. So if I have 1 is equal to sine x squared plus, okay, let's do thetas because I just like thetas. Theta cosine squared theta. That's Pythagorean theorem. Y'all all know that one, right? You have that one memorized. To get the other ones, just start with it and divide by either cosine or sine. So if I divide by everything by sine squared x, what is 1 over sine? What is 1 over sine? Yeah, say it. Yeah, cosecant theta equals 1 plus, and what's cosine over sine? Cotangent. Oh, is that the one we just used? And what if I want to find the other one? Well, I just take the base one I know. What, did y'all all catch what I did? 1 equals to sine squared theta plus cosine squared theta. And this time I'm going to divide by cosine squared theta. And if you practice this enough, you can do it in your head without thinking much. Doesn't take much, and you go, oh, I know what it is. Well, what's 1 over cosine? Secant, and this equals tangent plus 1. Did you ever wonder why they wrote them this way? Why they wrote 1 plus on one and tangent plus 1 on the other one? Because all the math teachers do this. I don't memorize those formulas. I just do that in my head real fast. So all I ever write down is 1 equals sine squared theta plus cosine squared theta, and I go from there. I only have so much memory left in my brain, so I have to take shortcuts. Okay, there's one more kind of problem I want to go over with you. Just to be thorough and make sure you've got all the tricks. Last one. If I give you y equals the integral of 1 plus square root of x over square root of x dx, we're going to rewrite that as powers. What does this look like? Have we done one like this today, except not fractional powers? How many things are on top? How many things are on bottom? Should you simplify this? Am I making my point yet? Please remember this. It makes it so much easier. The problem is I'm about to teach you more by the end of this unit, and then you're going to have way too many tools, and you try to use the last tool you used for everything, and it's not necessarily appropriate. You know what I mean, Jelly Bean? It doesn't always work. Sometimes the simplest approach is the best. Try algebra first to simplify. It's basically, if I teach you how to use a hammer, you think every problem is a nail. If I teach you to use a screwdriver, you want to think everything is a wood screw. And the problem is, then you try to use a screwdriver on a problem that needs a hammer. Doesn't work out too well. Don't forget the early tools. Okay, this is going to be, yeah, and it doesn't work real well. I've seen people really take out, because they try to do this, and then they take out the palm, the right edge of the palm of their hand. I've seen somebody do that when they didn't use a hammer. Because they missed. They got carried away and went, not pretty. Okay, is this going to become x to the negative 1/2 plus 1? Is that easy to integrate now? Use the algebra. So what does this become? Oh, wait, I messed up. Oh, well, it doesn't matter. I was going to do a different problem, but it's okay. So what's the antiderivative of x to the 1/2? X to the 1/2 divided by 1/2, which is the same as multiplying by 2. Yeah? And what's the antiderivative of 1? Plus c. I am done. Easy peasy lemon squeezy, yes? And you too can do this. Right? Okay.